Hi, 8th grade. We're going to change it up a little bit. We're going to do the skills and drills on the video instead of your shoot around. Actually, I do still want you to do the shoot around. It is on Friday. It is points for your team, so you want to do as many as you can. And also the exposure to some of those questions will help you prepare for the STAR test on next Tuesday. So what we have, we're getting into linear equations. Every day we have Chester, he runs the same number of miles, and the graph below represents the relationship between the number of days and the total number of miles Chester has to run, okay? What you have here, so we have on our X is the number of days, and so I have a graphic organizer here that will help you basically making a chart. So if you have 1 day, the total miles is 2. If you have 2 days, and you can go ahead and fill all those in, what are the total miles? 4, 6, 8, and 10. So what did I do? What did I do to my X, to the number of day, to get to 2? I multiplied it times 2. What did I do to 2? I multiplied it times 2 to get to 4. So I have a constant rate of change, don't I? We can also, we've done this before, I can find the change. What is 4 minus 2? 2. What is 2 minus 1? 1. 2 divided by 1 is going to give you 2. So remember that when you're doing linear equations, there's so many different ways that you can actually solve the question that's being asked. We also have something very, very important. If you have 0 days, you're going to run 0 miles. And we know that this line actually goes through what? The origin. And we know that when it goes to the origin, this is a proportional relationship. And when you have a proportional relationship, there is no B. You don't add or subtract anything to the original equation. So the formula for that is y equals kx, and we learned that in 7th grade. So when you have that, that means to solve for k, which is my 2, that's right, I'm going to do y, because remember here, when you solve equations, how do I isolate this variable? How do I isolate the change? I'm going to divide by x. So if I do it to one side, I do it to the other, which is y divided by x. 2 divided by 1, 2. 4 divided by 2, 2. 6 divided by, and so on and so on. So the rule here is going to be y equals, my change was 2, and I always have the variable x. And the equation, sorry, that should have been y equals 2x right here. So the coefficient is 2, and the constant, I don't have a constant here, is 0. And how many miles does Chester run every day? 2. The constant rate of change. And how many miles will Chester have to run after, how many miles will Chester have run after 12 days? That's right, all you're going to do is you're going to substitute your change is 2, and you put in the 12. So equals 24 miles. So remember that we use these rules so you don't have to count by 2, 4, 6, 8. Because what if he ran 100 days? Okay, yeah, it would be 200 miles. All right, so let's look at the next question. Melissa is saving $25 that she earned for washing her mom's car. Sorry, I'm looking at the time. She earns $10 every week for doing chores, which she also saves. Which function can be used to find T, the amount of money Melissa will have saved at the end of N weeks of doing chores? So already I know that this is actually my y. There's really nothing different. They're just using different letters for the variables, okay? Always read the problem once, then go back. Let's kind of isolate our important information. So she's saving $25 that she earned for washing her mom's car. Did that happen again? Did it happen more than once? No, this is a one-time deal. And then she earns $10. There's my key word right there, every. So $10 every week. What if it's 1 week, 2 weeks, 3 weeks? But it's still a constant change, isn't it? So I'm going to put my X here. That means that, I'm sorry, the number of weeks, we're using the variable N. So 10 N, so every week. And then a one-time, she already had the $25. I'm going to add $25. So you notice that I didn't even look at any of my answer choices. All I'm doing is I'm writing the equation from the scenario given. So which function she wants to use to find T, which is the amount of money, the total money, right? There you go. Now remember, sometimes it may look different. Nope. Looks like choice A it is. Now take a look at this one. Let's eliminate. You can't add those two because if I multiply the 25 times 2 times 3, that means that it happened more than once. Okay? And the same thing here, all they did was they subtracted the numbers. So be really, really careful. Your answer choices are going to look kind of nice, just like this, because they're gonna play with these numbers just to have, because some students they don't know what they're doing. Look at this one. So the 25, this is not the one that we're going to multiply every week. It happens only one time, which will give you A. All right. Number 3. Okay. So we have a graph of the line y equals 2x plus 3, and it's drawn on the coordinate below. Okay. And they want to know which table of ordered pairs contains only points on this line. This one's simple, right? All you have to do, well, one is plug in a value. Plug in a value, let's say 1 and 5. Is 1 and 5 on the line? Yes. Is 3 and 9 on the line? Yes. So all you're doing, now let's look at this one, is 5 and then y equals 1. Is that on the line? No, that one's out. Okay, this is pretty simple. So is 2 and 1 on the line? Nope. Because remember, every single point listed in this table should be directly on that line. Let's pick 1 and 5. So I have 1 and 5. That one checks out. So do you notice how we might have a problem? So this is, let's go back to this one and let's make sure. Is -2 and 1 on the line? No. So you see, they have a common, you have to check all of these to see if they're on the line, because what they'll do, obviously, oh, okay, yeah, that's on the line, and you'll check it, but look at what happened. It's actually this one. So I'm going to do every single one. So -2, -1. That one checks out. And I already did this one. 0 and 3. That checks out. And then I have a 2 and a 7. And that one checks out. So my choice was actually D. So just words of wisdom. Be really, really careful on tables. When you find something that does work, don't always assume that that is going to be your correct answer. Okay, always check the other ones just to make sure. All right, so we're going to do one more. Actually, we may be able to do a couple more. All right, so which line, graph below, best represents the table of values for the ordered pair x and y? Same thing here. And in fact, what I want you to do is I want you to do this one by yourself. Okay, because really it's just an extra practice for this one. So you can pause the video, do it now, whatever you'd like to do, and we'll go over it in class when you come on Friday. All right, let's look at number 5. Which situation could be represented by the graph below? Well, first, before I even look at this, I'm going to look at my graph. I read my x-axis, and it means the number of hours, which is time, determines how much money I make. Yep, I already got it's going through the origin, so it is proportional. Okay. I could go ahead and find my rate of change, or I could say 6 divided by 1, right? Here's a point. So my change, my K, is going to be what? Is 6. 6 divided by 1. So let's read the different scenarios. If a babysitter charges $6 per hour, how much would she earn for X hours? That could work. If it takes 6 hours to spend $1, how long? No, what B is saying is 6 hours to spend $1. That's not even on my line. If a landscape company charges 30 plus, that's a one-time fee. Okay? And $6 per hour to mow your yard, how much would they charge for a job that takes X hours? Now the difference in this would actually be Y equals 6X plus 30 because you have that one-time fee. That one is out. That is a non-proportional. And we know that this one is out. If it costs $6 to travel 1 mile, how much would it cost to travel X miles? No. If it costs $6 to travel 1 mile, how much will it cost? So 2 miles. Well, one, they're using miles as your X. This has to do with hours. Okay, so that one's not going to be. It should be A. All right, we do have a little bit more time. We'll do one more. The graph below shows the shopping distance for a certain car, depending on the speed of the car when the brakes were applied. If the car needed 210 feet to stop, approximately how fast was the car traveling? Okay, so let's see. This is the distance, and this is the speed. And it looks like this is a curved line, which is not a linear function. But what we can do, this could be a trend line, sorry, but it didn't. It looked like they were trying to model a line. All right, so if you needed 210, which would be about right here, because you have 200 and then 250, I'm just going to go up just a tad, okay? Looks like a trend line, yeah. So a trend line should have been like this. Okay, so that means that it hit my line right here, which means that I need to be between 50 and 60 miles per hour, okay? So this actually looked like a curved line. That's why I apologize. It was actually a scatter plot, and they wanted you to draw the line of best fit, where you're gonna have the same amount of dots on on both sides of your trend line. You kind of just put it in the middle. So then when they would say 210 feet, okay, you find the axis that's talking about feet. You draw a line all the way over to where your trend line stops, and then you go down. It's between 50 and 60. I know 40 and 50 would have been out here, right? That is not on my trend line, okay, when at 210 at all. 70 and 80 would be all the way over here, and then 60 and 70 is all the way over here. So it has to be B, okay? All right, what I want you to do is I want you to look through, I want you to do these two problems by yourself. And it looks like we've seen this one before, so it'd be a great way to go back and review that. I want you to do these three by yourself, and then we're going to talk about them when you come to class. So number 4, 7, and 8. So I didn't take too much of your time, only about 15 minutes. Take about another 10 minutes to do those problems and work on your shoot around. See you tomorrow.